The question says that a conducting sphere of radius 10 cm has an unknown charge. If the electric field 20 cm from the center of the sphere is 1.5 into 10 to the power 3 Newton per Coulomb, points radially inwards, what is the net charge of the sphere? So the question is saying that there is a conducting sphere of radius 10 cm and it has some charge due to which there is an electric field 20 cm away from the center, and the value of electric field is 1.5 into 10 to the power 3 Newton per Coulomb, and this electric field is towards the sphere. So since this electric field is directed towards the sphere, so we can say that there is a negative charge inside the sphere. Now we have to find out what is the net charge on the sphere. So by Gauss law we know that for a spherical charge distribution, electric flux would be equal to Q enclosed divided by epsilon naught. Here electric flux is the multiple of electric field multiplied with the surface area of the surface enclosing this charge. Now for a sphere, the surface area of a sphere would be 4 pi r square. Now E dot 4 pi r square would be equal to Q enclosed divided by epsilon naught. Q enclosed is the charge inside the Gaussian surface. Now we can find out the expression for Q enclosed as here as E dot 4 pi r square multiplied by epsilon naught. Here E would be equal to 1.5 10 to the power 3 Newton per Coulomb, and this is the surface area of the sphere of radius 20 cm, and this is epsilon naught. Now we know that the electric field is pointed towards the sphere, so there is a negative charge inside the sphere. Thus the charge would be minus 6.67 nanocoulomb. Thank you.